Hello and welcome to Ever Growing. Today we're going to explore one of the most fundamental aspects of human existence, memory. What is memory? How does it work? And why do we forget? Let's dive in together. What is memory? It's hard to overstate the importance of memory. Memory is what makes us who we are. Some memories are ones we are aware of, like the coffee you enjoy with a friend, the time as a child when the neighbor's dog scared you, or knowing that spiders have 8 legs. These are known as explicit memories, ones we can consciously recall. But there are also implicit memories, which may be even more important. For example, when you talk, you are using motor memories to move your lips and tongues to produce sounds you've learned. When you walk, you are using motor memories to coordinate your gait. Without memory, we would just be bodies, unable to communicate or recognize danger, and much like newborn babies, oblivious to how to survive in the world around us. In short, memory is crucial in transforming us from helpless newborns into capable adults. How are memories made? Memory is the process of encoding, storing, and retrieving experiences and knowledge. Its many forms are even more important than you might think. Memory's role in allowing people to understand, navigate, and make predictions about the world is crucial. Personal memories provide the foundation for a rich sense of self and life and give rise to experiences such as nostalgia. Encoding is the first stage of memory. It is the process by which the details of a person's experience are converted into a form that can be stored in the brain. People are more likely to encode details of what they are paying attention to and details that are personally significant. Retention or storage is the stage in which information is preserved in memory following its initial encoding. The stored memories are incomplete. Some of the information encoded during an experience faded during retention, sometimes quickly, while other details remain. Memory consolidation refers to the neurobiological process of long-term memory formation. The hippocampus and other parts of the medial temporal lobes are critical for many forms of memory. The cerebral cortex, the outermost layer of the brain, as well as deep-seated structures such as the basal ganglia and the amygdala, are also important for memory, including the integration of emotional responses into memory. Memory involves changes to the brain's neural networks. Neurons in the brain are connected by synapses, which are bound together by chemical messengers, neurotransmitters, to form larger networks. Memory storage is thought to involve changes in the strength of this connection in the areas of the brain's linked to memory. After memories are stored in the brain, they must be retrieved to be useful. Retrieval is the stage of memory in which the information saved in a memory is recalled, whether consciously or unconsciously. Retrieval includes both intentional remembering, as when one thinks back to a previous experience or tries to put a name to a face, and more passive recall, as when the meanings of well-known words or the notes of a song come effortlessly to remind. Then, why do we forget? Forgetting can manifest as inattention or can happen because the brain doesn't reinforce a memory long enough to store it. Research suggests two main theories as to why memories are forgotten. First, decay theory. This theory infers that if a certain memory isn't repeated, it will eventually deteriorate. Second theory, interference theory. This theory infers that New information received by the brain replaces old information, such as the inability to remember an old password after you have created a new one. Why do some memories last longer? Memories form when collections of neurons in a region of the brain called the hippocampus activate in response to a particular experience. Each time you recall the experience, the same set of cells activates. When one neuron repeatedly activates another, the connection between those neurons strengthens. In lab experiments, researchers investigate whether blocking the interaction between qbi and PKM-zeta influences long-term memory performance in mice. They found that blocking this interaction impaired the mice long-term spatial memory. qbi is the missing link in the long-term memory, serving as a persistent synaptic tag that sticks to a strong synapses to PKM-zeta while avoiding weak synapses. This persistent synaptic tagging mechanism explains results that are clinically relevant to neurological and psychiatric disorder of memory. That is for this episode of Overgrowing. Memory is the vital aspect of who we are, how we learn, and how we function in the world. Thank you for listening. If you enjoyed this episode, please subscribe and share it with your friend. Join us in the next episode as we continue to explore topics that impact our daily lives. Until next time, stay informed